that the astronauts read out.
Gravitational effect of those planets.
Hey, I'm Kristen, and this is NASA Now for February 1st, 2012. The electromagnetic spectrum contains visible and invisible ranges of light. NASA is about to launch a new space telescope that will give scientists the ability to see parts of the universe that have been previously invisible. We will talk with an expert to tell us about this exciting new telescope. That's ahead. First, here's what's happening at NASA Now. NASA Spitzer Space Telescope continues to provide stunning images from deep space. This spiderweb-like tangle of gas and dust is a star-forming region called 30 Doradus. It is one of the largest such regions located close to the Milky Way galaxy. Scientists estimate that there are about 2,400 massive stars in the center of 30 Doradus, also known as the Tarantula Nebula. A nebula is an interstellar cloud of dust, hydrogen gas, helium gas, and other ionized gases. Nebulae are often star-forming areas where gas, dust, and other materials clump together to form stars. Today, we are going to learn all about the new imaging telescope that NASA is launching called NuSTAR. This is a different kind of telescope that will give scientists an even better picture of the universe. To explain what makes this telescope so special is astrophysicist Dr. Ann Hornschemeier from the Goddard Space Flight Center. Hello, Ann. What is NuSTAR?
NuSTAR is a small explorer mission that will be launching very soon. It is going to, for the first time, focus hard X-rays into images. And I don't know how revolutionary that sounds, but it's a big revolution because we haven't been able to actually focus X-rays. And the result is it's going to be a much more sensitive view than we have ever had before of the hard X-ray universe. And it turns out that the universe is actually emitting an awful lot of light at hard X-rays.
What do you mean by focusing hard X-rays into images?
It means more or less that we've got an X-ray camera now, and we're going to take the X-ray camera and we're going to take a photo, and then we're going to pinpoint where the black holes are. And we'll be able to do things like say that black hole corresponds to this galaxy. Since we know how far away this galaxy is, we know how far away the black hole is, we can start measuring the properties of the supermassive black hole.
X-rays are part of the electromagnetic spectrum. Can you tell us why this telescope is measuring X-rays?
The electromagnetic spectrum is basically light. When we think about light, we tend to think about just the little visible part of which we are aware because we can see it. But the full story, if you will, of light ranges over quite a broader range than visible light, from radio all the way up to gamma ray emission. The advantages of a telescope like NuSTAR that studies more than just visual light is that we get to see the rest of the universe. And for instance, a large fraction of the normal matter in the universe, that is the stuff that I'm made of and you're made of, the majority of that normal matter out in the universe is actually really hot. And when I say really hot, what do I mean? I mean millions of degrees to tens of millions of degrees. And that light is so hot, something funny happens. The light actually comes out, it's invisible in the optical light. And it's sort of funny to think that you could have this huge amount of matter sitting out there and you can't see it until you look in X-rays, because gas that is millions of degrees hot can only be seen in X-rays. And you basically see the violent universe, and it is. It's the hot, violent universe, you know, the most dramatic things that are happening. Gravity disrupting stars, and those sorts of things are visible at X-ray wavelengths.
What do you hope to learn from NuSTAR?
I'm very excited that we'll be able to look at nearby galaxies and start studying black holes and neutron stars, not just in our own galaxy, but in other galaxies at hard X-ray wavelengths. So I think NuSTAR is really going to push the boundary of understanding high energy processes in the universe.
Scientists use many tools to learn about distant destinations. Check out this project with real data straight from Mars.
You and your students can analyze data collected by Mars spacecraft using 3 different forms of electromagnetic energy: visible light, infrared, and gamma rays. Look for electromagnetic spectrum remote sensing ICEs on Mars, which can be found on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to look us up on Facebook and leave a comment about today's program. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.